Yeah, go ahead.
All right, welcome everyone to the last session. My name is Steve VanderLeest. I'll be presenting with Matt Kelly, and our presentation is a call for an Aerospace Working Group. Can you all see my slides?
You can.
All right, very good. Just want to make sure you could see what I was talking about. I'll quickly introduce the two speakers, talk about the existing working groups. Then Matt will go over the benefits of adding aerospace as a new working group and some of the goals that it would be, and I'll close up with what the mandate would be in next steps. So two speakers today were both from Boeing, located in different parts of the country. And until we did this presentation, I didn't realize we actually did our advanced degrees at the same place. So go University of Illinois. So you've already seen in previous presentations this morning a good rundown what the different working groups are. I've tended to think of them as those are technically focused. So those are listed there. We've heard from several of them today already. And then two which are focused towards particular industries. And as you've seen in previous presentations, one of their primary work products are use cases for the technical groups to focus on. Just as a note, Boeing recently joined ELISA, and we are hoping to have Boeing engineers joining most of those technically focused groups in addition to the working group we're about to propose. So first, I wanted to note that Linux is being used in aerospace. It has been certified on avionics systems in the United States, but typically at fairly low assurance levels. In aerospace, software levels are defined from A being the most rigorous down to E, the least rigorous. So it's the opposite of how automotive does it with ASIL. And so to our knowledge, we've seen Linux systems up to level D as in Delta, so fairly low assurance levels at the moment. And it's hard to find any information about these systems because companies have kept it quite private. There's not a lot of publicity or publication around what's been done so far. ELISA can help with broadening the use of Linux in this safety critical domain, including helping get it to higher levels of criticality and also getting buy-in and a comfort level from certification authorities. There are a variety of them. In the US, the civilian authority is the FAA. In Europe, the European Union, it's EASA. The US Space Agency, NASA, has its own set of standards. And then in the US, the DoD, each military service has their own airworthiness authority. So the US Army has a airworthiness authority, US Navy has their own, each having their own standards. There's some overlap and cross-fertilization between them, but those are the primary approvers that decide whether an aircraft is approved to fly. There are a number of aerospace platforms that require some level of safety assurance. So you can think of the traditional jetliner, a Boeing 787 being certified for flight and used for commercial flights. But there are a number of other areas that are emerging now, air taxi, electric vertical takeoff and lift, drones, both consumer and commercial. So all of these have some level of a need for safety assurance. Matt and I are coming from more the traditional area of aerospace, but we certainly see that these are these other areas that are also important. So Matt's going to talk through then benefits and goals, and then I'll come back when he's done.
All right, thanks, Steve. So yeah, going to talk about a little bit of the benefits and goals. So the first benefit is kind of the obvious one. We want to add new use cases. And so I want to talk a little bit about the why we think that's necessary. So we acknowledge that, each industry is kind of regulated by a different standard. For aerospace, that's DO 178C on the commercial side, or the military's, the US military's level of rigor, for instance, in the US. And other industries are regulated by other standards. So for automotive, that's ISO 26262, which is where most of the effort in ELISA has seemed to be focused. For all those different standards, there's a lot of commonality between them, even some standards like you see listed there that span industries. But there's a bunch of unique things too. The canonical example that Steve and I like to use for aerospace is at DAL A, there's a requirement to do source to object code tracing to ensure that all of your object code has actually been tested as well. That doesn't really appear in the other standards, and it's a particularly hard objective to actually pull off. And so we really want to make sure that ELISA is thinking about the aerospace specific use cases as well. A ton of good work going on, but we've seen it in the previous sessions we participated in. It seemed very automotive focused, and so we want to help to broaden the lens by adding new working group, a new working group focused on aerospace to make sure all those needs are addressed. Next slide. Okay, the second benefit is to create a home for experts from the aerospace industry. So the aerospace industry has been doing safety critical software for a long time. The first version of DA-178C came back out in the 80s. And so there's a rich tradition in the aerospace industry of creating safety critical software. What there isn't is a long legacy, or at least a long open legacy, of using Linux in those applications. So we know Linux has been used, like Steve said earlier, but we really want to raise the profile of using Linux in all use cases across the aerospace industry, like Steve said, not just commercial, but any application where it could be used, really focusing on creating a path forward, like many of the other speakers have said. And then the third benefit is increased legitimacy. So of course, one of the benefits of creating those new use cases is that we'll drive the technical groups to create sufficiently generic solutions that apply to multiple use cases. And we think that really enhances the argument to be made. If you can only argue in a very specific use case, then maybe other cert authorities aren't going to accept your argument. But if we drive it to be nice and generic, we hope that the cert authorities will buy into it more clearly. So adding each industry kind of brings additional expertise. Like we said with the previous bullet, there's lots of expertise in the safety realm, and there's also lots of expertise in the Linux realm in aerospace, and we need to bring that together to make a path for Linux. And then, of course, regulatory authorities are definitely going to be more interested to listen to you if your industry is accounted for, right? If I propose an automotive solution to the FAA, they might look at me like I'm upside down a little bit. And we really want to make sure that the FAA, we're addressing the concerns of EASA, the FAA, whatever cert authority it is that we're talking to. And of course, we're going to let our regulators lead us, right? We're not going to try and do things that they don't buy into. We really, really have to get their buy-in when we do these kinds of things. And so we want to drive arguments that they will believe in. Next slide. All right, so Steve and I took a cut at creating some early aerospace working group goals. And these are really more the philosophy level, not the immediate next steps. So the first thing is we don't want to duplicate work that the other working groups have done. Like we said earlier, there's a lot of common concepts like traceabilities and peer reviews and requirements. We don't want to recreate everything in the aerospace working group with our little extra spin. We want to try and use what's common and not really look at those specific areas. We want to embrace that and look at the areas that are unique, right? The second goal, like Steve said, there's not a whole lot of open documentation on where Linux has been used in aerospace applications. So we want to actually go document what is out there. So, there are some projects like Linux-based drone operating systems that we want to go look at and kind of pull in some documentation. Probably the most well-known example of a Linux application is SpaceX. We want to try and go find what information we can that's out there about the SpaceX application. I know there's at least some papers that talk about how they did that, and we want to use the knowledge that's out there and flow that into this working group. And then, of course, retouching on creating new use cases. The working group's going to try and find a sufficiently open use case so that we're not touching on anything proprietary from anybody's day-to-day work, but a use case that highlights the unique needs of the aerospace industry with some sort of realistic complexity. So, we're never going to achieve the complexity that we probably see in our day jobs And we want to balance that, right? We want to have something that has realistic complexity, but is also approachable to folks who want to join, because after we get rolling, we don't want the use case to be so complicated that no one can come in later and understand what we're doing. And then, of course, one of the particular aspects that we want to focus on in the early going is kind of the real-time performance requirements that a lot of the aerospace embedded applications require. And with that, I think I'll hand it back to Steve.
Before I jump off the slide, I just wanted to make a connection back to an earlier presentation. Paul Albertella was noting in his presentation that a lot of the standards tend to apply at the system level, not necessarily directly to software. For aerospace, there is a system level standard, but there is one more specifically, the one mentioned on the slide, D178, which does apply directly to software. It's primarily about software. So our industry is maybe a little bit different in that respect compared to the automotive and medical areas, in that we've had this standard out, as Matt mentioned, for decades, focused specifically on software, where it then defers to a system level for hazard analysis and overall safety analysis. There's other standards. So Matt and I tend to live in this world of the DO-178 standard, especially on the civilian side. All right, so we want to just briefly mention what the industry-focused working groups that exist today, what their mandates are. You can go look these up, but I want to just summarize them here for you to take a look at, and then we'll suggest what we think the aerospace working group mandate might look like. The automotive mandate, I found two places. On the overall web page, it lists a somewhat more extended description of the working group, and then on their GitHub page, they have what they specifically mention as a mission statement, and they're consistent with each other. So you can see the words there. I don't have to read them for you, but you can see they're focused on automotive, coming up with use cases for automotive. The medical devices working group has a very short, to the point statement. So I'll read that one off. In the context of medical device safety standards, develop best practices to analyze systems and identify the components of Linux that will be participating in safety analysis. So again, a focus on their industry, but looking at, how do we do it in this industry? And then the thought is bringing a use case back out. So those are the two industry-focused working groups that exist today, just for reference. So we had in mind then, as a proposal for the aerospace working group, that there would be three areas that we'd focus on that are consistent with the others without duplicating effort. So first, obviously, we're looking at one or more use cases from we'll face the same difficulties that the other groups are, that probably the most interesting use cases are the ones that we cannot share. We're hoping we can find some use cases that some of the information can be shared, and so that those are available for the group to work through overall. Then secondly, work towards requirements specifically that are needed for an operating system that would support avionics, something that would drive into those processes that show traceability from requirements to design to test, and tie that all into the code. And then third, looking specifically at software lifecycle processes. As was mentioned in an earlier presentation, the standards typically assume that you're working from scratch with a design process that was developed for safety, and then you develop design and code from there. We have the existing code base of Linux, which has been crowdsourced tested by millions of people over decades of time. So it's got a very useful field testing and pedigree, but not one that typical safety authorities, like in aerospace, would necessarily think about as legitimate. So how do we tie those things together? How do we provide the proof of correctness, the assurance that the system is safe when using Linux, leaning on all the work that's been done before, but then filling in gaps where we need to demonstrate something that hasn't been traditionally done in Linux, and especially for us at higher assurance levels. So that is levels above what we know of so far, level D, moving into level C and higher. So that's what we're thinking of in terms of mandate, and this is a work in progress. So where would this go next? We will need to flesh out what the governance for the working group would be, looking at what the existing groups have, and then come with a formal proposal. So this is kind of our work in progress today. We're hoping that others have interest and would join with us in proposing and engaging in this new working group, but we'd bring that proposal to the TSC. Presuming they approve, we then would get set up like the other groups are, establish a mailing list, establish a set of meetings, and so forth. We'd want to recruit then by publicizing, advertising that this group exists, and then recruit broadly. So one of the questions that some of the organizers, Kate and others, have asked us was, who would this be for? So we tried to kind of bullet that out a little bit. We think it would be for anything that flies, aircraft, spacecraft, et cetera, that has some need for safety of flight. So this could even be software on the ground, for example, air traffic management. So it doesn't necessarily have to be software on the thing flying, but it's related to that thing flying. It doesn't necessarily have to have a pilot on board. It could be autonomous systems, maybe more so there. It does need to require, it's got complexity that requires an operating system. So it has to have a need for Linux, and then it's under some sort of oversight. And so we've listed, and I mentioned at the beginning, there's a number of different authorities that grant flight certification or airworthiness in some way. So we're sort of thinking this is the group that is interested. You're flying in some way with software that is hard enough you need an OS, and somebody is overseeing you. So we think that's actually a pretty big group of folks that would be interested in this group and could participate. So those are what we think are the next steps that we would pursue. So that brings us, how are we doing on time? Yeah, we've got time for questions if you have any. And I'll give Matt the hard ones. Let's see, we've got one question on the chat. My research is focused on both the avionics and space domain. Indeed, we've noticed a lack of open use cases of these domains. For this reason, we've developed ESA, a set of open source representative space-related full applications. This sounds great. They are not developed according to DO 178 or ECSS, but maybe they can be used as a starting point. Leonidas, that sounds fantastic. So I don't see a question there, just a comment. It sounds like you are interested in working with us. Thank you for that comment. John Dikema asks, what is the time frame for getting this work group established? We plan to move quickly into developing the proposal and submitting it to TSC. So I would say it's weeks and months we would hope that happens. I don't know, maybe Kate can answer how long it might take for this to move through the TSC. I don't know how long it's taken with other groups, but we coming out of this presentation, we want to move it right forward. So yeah, hopefully this year. Kate, do you want to speak to that? What's
Sure.
sort of the time frame?
Depending on if we've got critical mass of people wanting to participate and expressing interest, like Leonidas just did, we can probably do it within a month.
Okay, fantastic. So that's kind of what I was saying, weeks or months. So fantastic.
Yeah, we just need to gather together the people that are interested and then let them figure out a time that works for them to talk about this and then start to flesh it out as a group together.
Yeah, absolutely. So, Matt and I are hoping to facilitate a broad group. We happen to be from Boeing, but we know there are many people around the industry that we think will have interest in this. And I see several people popping in on the chat as well. So that's fantastic. Leonidas has a question I can't answer. If his organization is not an ELISA member, what does that mean about involvement in an avionics working group? Okay, and somebody's posted.
It's just show up. Everyone is welcome. And if you want to, like I say, if you want to just join in and start participating in the group and start picking up work items, that's a big contribution too. If you want to see that this element is valuable and join your company, join over time, that helps us as well to keep the infrastructure going. But
yeah, absolutely. We'd love for people to get started then, however they can, but we're hoping others will become members of ELISA to help drive the overall organization forward. Okay, now I see a couple I can answer. Are quadcopters, drones used for safety relevant application scope? Absolutely. It flies if it's being used in most countries. If it's being used in your population, there are regulations being levied against it. So that certainly would be of interest. So we're trying to keep this definition fairly broad, and so drone usage with safety regulations in mind would certainly be interesting. What is the definition of critical mass? I think TSC will have to decide what that exactly means, but we'll proceed and see where it is. You've seen that some of the working groups really only have a handful of people that are actively engaged. I would want that. I certainly want to do this challenging, very ambitious project, with just a couple people. So we need a good group of engaged folks, and then a broader group that can occasionally provide input as well. Sub asks, are payload flying components, onboard processing not related to safety parts, part of the working group too? Yeah, I would say, initially, yeah, we would say yes, but our focus is going to be on the safety area. So it would be, our use cases are going to be working around software running on hardware that is providing some safety critical functionality. If something goes wrong there, bad things will happen. That's where our focus is going to be. The other parts around it, are of interest just in terms of that forms the overall system. And so we want to stay compatible there, but focus will be on safety.
Yeah, I guess I would add there
ahead,
that we will probably be looking at somewhat mixed criticality scenarios, like Philip was talking about earlier in the safety group. How do we host a non-safety critical and safety critical together? So that might be an application where what you're talking about is that makes sense to include.
Yeah, great add-on, Matt. Thanks. Wanja asks, we are currently building an ARINC 653 emulator, which runs on Linux to allow for a common, hopefully soon open source platform to allow anyone to tinker with an environment related to avionics. Could this be, I'm guessing saying, could this be helpful? Yeah, absolutely. I will say, ultimately, we'd probably want to look at a system like was presented earlier, where you've got ARINC 653 as the underlying partitioning environment, for example, be on a hypervisor rather than the emulator above it. But in terms of getting started, I think there's lots of different ways we would want to approach this. Thanks. I see some people expressing appreciation. That's great. Wanja finished it. Could it be hosted in the ELISA Avionics Working Group? I would think so. ARINC 653 is a standard that is primarily used in aerospace. I'm not sure if it's used in the other industries or not, but I know definitely heavily in aerospace. So sounds like a good home for it. All right. We've got a couple minutes yet. Any other questions? Richard says, does any of the safety regulations requirements change when dealing with active war zones, specifically for drones? Oh, very timely question. This is not my area of expertise, so I'll let Matt jump in, but my initial answer is on the military side, at least in the US, there are standards for safety that focus on safety for, say, a pilot of a military aircraft. Sometimes they do lean on civilian standards like that DO-178 that I mentioned, but sometimes they're a little bit different. And what I don't know is about unmanned aircraft like drones. I imagine that even there are standards of sorts. But of course, that's a very interesting and challenging and limited sort of region that you'd be flying in. So good question. We should pursue that further. Matt, do you know more about that?
I don't have a direct answer. I'll say that on the military side, the projects I've seen, the safety related aspects were more for piloted aircraft. And so I know there is some different guidance for UAS, as they like to call it, unmanned aerial systems, I think. And so I'm not super familiar with that, so I can't provide a direct answer, but I can imagine that the answer to your question is yes. I just don't, I can't confirm that for sure.
Great area for the work group to explore and maybe pull in some people that do have more expertise. Certainly timely, been in the news. Wanja mentions we try to open source the coming month and gives a URL there. Great. Any other questions as we wrap up? Thank you. I appreciate. We were, hoping that a few people would show up. So I think I saw 40 or 50 people there on the call. That's fantastic. I was getting nervous. No one would be interested. So we're delighted to see this interest here. Please tell your colleagues at your company or those that in the industry through your, professional connections so that we do get that critical mass, so that we get, broad representation across the industry to drive this effort forward. Question timeline to start in our list. We want to get approval from TSC first to start the working group. We've gotten some, positive signs from them, encouragement so far, but we have to make that formal, get their approval, and then shortly thereafter, maybe in a month, we would see that the mailing list would start up. In the meantime, if you're interested, we'll try to grab the chat contents here. Kate, Evie, is somebody able to grab that complete chat and share it with us?
Because anyone who has confirmed, we are able, if anyone is, let me start over. If anyone in the chat says that they would like to join, we would be happy to share that, and we can forward that through Kate and then.
Great, thank you.
Yeah.
And if you haven't hit the chat, on the slide is my email address there too. So feel free to reach out to me directly, and one way or the other, we'll gather those that are interested into a group.
Mm-hmm. If anyone wants to just reach out to me directly as well, I'm happy to vector everything and help Steve and Matt basically pull it together. So if you know my email, feel free to reach out to me too.
Excellent. And you can find Kate on the ELISA site. So, right. So you know how to find her by browsing to it. So very good. And these slides are posted as well on the Summit site, so you can find that. Any other questions?
Steve, maybe go back one slide. Joe asked what the next steps are, which you touched on. But
yeah. Let's see if I can. Oops. Did I end up stopping sharing, or can you still see that?
We can still see it.
All right, there we go.
I can't see it, I'm afraid. Sorry.
Let's see. Yeah, I dropped out of
there we
play
go.
mode there.
You can see it now.
So,
there we go.
So yeah, a couple of people again asked what next steps. So first, we need to formalize a proposal, bring it to TSC. Next, TSC has to consider it. If they approve it, then we would be set up as a formal new working group. We'd get a mailing list and start scheduling meetings. I listed kind of recruit folks after that, but really would like to start now recruiting people that are interested and continue that even after we're formalized.
Yeah, we'll set up something for a temporary mailing sort of deal until it's formalized for the formation aspect. Okay. So
fantastic.
just
Thank you, Kate.
let Steve or myself know, and we'll work with, we'll get something started so that people can start to communicate and brainstorm as to how, the scopes and missions and so forth.
Yeah, very good.
Build some consensus. Okay. Thank you very much for going through this. Very much appreciate it.
Thank you. Our pleasure. We're excited to get this started, excited to work with the other folks that are indicating interest. Thank you.
Yeah, thank you for everyone who's voiced some interest and for listening to us today.
And just